Now that you have created your first smart contract, I think it's time to talk a little bit what happens behind the scenes. What are those programming languages? What is Solidity? And how is this data field actually populated when we send off a transaction? So this is why in this video I want to talk about smart contracts and how they are actually working. So what is a smart contract actually? Well, the term smart contracts isn't so old. It was coined by a guy named Nick Szabo in 1994. He's a computer scientist. So this is where this comes from. And there are a couple of articles online which are like not so smart contracts and so on. But I think still it's a very interesting term to call automated transaction handling smart contracts. What is it? It is a piece of code that is running on the blockchain. In essence, the blockchain or a smart contract is a state machine. It has a specific state that is, in our case, it was the state of the string. My string was hello world. And if we had some functions to influence that, we would need a transaction to change the state. And you can have an arbitrary amount of variables in your smart contract and can do logic operations with it. Then these state changes, when you send off a transaction, the transaction needs to be mined. So state changes from one state transitions happen through transactions and mining. That is very important to understand. Just because you send off a transaction doesn't mean you have changed the state. It needs to be mined as well. And in theory, at least, from the design of the programming language, Solidity is Turing complete. You can solve pretty much any computational problem in Solidity. We have a couple of programming languages for smart contracts, and the point is they are all getting compiled. And what you actually send off to the blockchain is EVM bytecode. So when you remember those data field, which I was briefly talking about, where I said we are sending off a transaction and have a look at the data field is populated. This is actually not the source code that you are sending. It is compiled code. So it is like a binary that you're sending off, and this gets baked into the blockchain in a block, and then you can run that on the blockchain. There are other languages, and they are all getting compiled down to bytecode, but Solidity is one of the most famous and well-maintained ones. It is also the reason why this course is building on Solidity, because it's still the most famous one. It is derived from ECMAScript. This is why it is very often compared to JavaScript. I personally think it doesn't have a lot in common with JavaScript, especially from the language design. I am still not sure why people think that it looks very much like JavaScript. I think it doesn't look at all like JavaScript. Just the underlying architecture of the compiler was actually derived from ECMAScript. So this is maybe where this confusion came from. And it has to be compiled down to bytecode, as I said before. Then if you deploy a smart contract, if you run the smart contract on the blockchain, then every participating node in the network executes the transaction and makes sure that the transaction is valid. Because every node in the blockchain has a copy of the blockchain. This is why it is one shared ledger across all participating nodes. As I said before, there are other languages, and I think the second most popular language right now is Vyper. I think it's written with a Y actually, Vyper, not I. It was invented by Vitalik, as far as I know, Vitalik Buterin, research-oriented language, and the reason is because Solidity is very error-prone. You can make a lot of mistakes in Solidity, and he wanted to have something that is a little bit less prone to errors, so you don't have to take so much care as in Solidity about the errors that you're writing. Luckily, you subscribe to the right course. We are going through all of this. Other languages were Serpent. It was similar to Python. I think maintenance has stopped. LLL is low-level Lisp. I'm not sure if this is still maintained, still in active development. Mutant was a Go-based language for the EVM. I think it's deprecated, and I don't think that anybody knows about this anymore. Now we have written our Solidity smart contract, and you saw we started with a Pragma line. The Pragma line is the first line that you would start a smart contract with. You can see a smart contract has some sort of a class-like structure. It contains functions, it contains control structures like if-elses. It can have loops, for and while loops. It can have different data types. Everything is statically typed. So if you have unsigned integers, you cannot dynamically convert them into something else. You can cast them into something else, but you cannot, like in PHP or in JavaScript, where you can convert data types dynamically. We are going through all of these data types in this section. You can have inheritance, and there are a couple of special data types and special structures, which are, I believe, I've only seen them in Solidity. Those are modifiers and the way addresses are handled and so on. So this is very special to Solidity. We're having extra lectures about that, and you can import other files, so you don't have to have a 2000 lines Solidity file. You can split them up into other files, which is very handy. There is a style guideline for Solidity files. So in the Solidity docs, a contract starts with a capwords style. And then inside the smart contract, you have curly brackets. And smart contract starts with curly brackets. And inside these curly brackets, you have everything. You have the so-called storage variables. You have events, modifiers, functions, a constructor, and whatnot. So definitely stay tuned for the next lectures where we're going through all of this. Then the version Pragma is actually a pre-compiler statement. It's not a compiler statement. It is here to lock in the compiler version, and that is actually very important. It's a security feature to make sure that when specific language features change, that your file doesn't become insecure. So the ideal is actually to lock into a specific compiler version if you do this in production. We're also going to talk about this in a specific section about smart contract security. For now, we can just keep working with Pragma Solidity, and then the caret 0511 or 050, it makes no difference for this course, for this section. So here are the key takeaways. The smart contracts are running on the blockchain. They are deployed as bytecode. So you're not deploying Solidity code, you're deploying bytecode. So this is why when we are talking about the blockchain, the Ethereum blockchain, that there is the EVM, the Ethereum virtual machine layer, which is, the EVM is copied by a lot of other blockchains to run similar bytecode on a transaction basis. They are Turing complete, and probably it looks very familiar if you are a developer. Shouldn't look too unfamiliar. There's just a couple of specifics on the Ethereum blockchain that you really have to be careful with. And this is why you should stay tuned and watch the next lecture.